right, this is either number 16 or number 17, depending on the version of the test that you had. But it's cotangent squared plus 3 cosecant plus 3. So again, we want to keep our singlet and substitute for our squared. And our squared here is cotangent squared. So I'm going to write out my sine squared plus cosine squared equals 1 and get to cotangent squared from there. Cotangent squared, I know, is cosine squared over sine squared. So if I'm going to get cotangent squared, that means I need to take my basic Pythagorean identity and divide everything by sine squared. Sine squared over itself is 1. Cosine squared over sine squared is cotangent squared. And 1 over sine squared is cosecant squared. So if I want to substitute in for cotangent squared, what I need to substitute in is not 1 minus cosecant squared, it's actually cosecant squared minus 1. And that was a common issue. So cosecant squared minus 1 is what I'm going to put in for cotangent squared. Unlike the problem with sine and cosine on the test, once you do that, you don't have to, here you don't have to drop in parentheses, there's no distributing. Everything is on the same side of the equation, so you can just combine like terms and solve. Do be careful when you're combining like terms, you're on the same side of the equation, so -1 plus 3 is going to give you +2. If u's are helpful here, you would let u equal cosecant, so you'd have u squared plus 3u plus 2. Then you can just go to your shortcut from here. What are two numbers that multiply to 2 and add to 3? Well, they are 2 and 1. So the factoring with this problem is much easier. It's just that first step, identifying the identity that you need to swap in is a little bit trickier. So u equals -2 and u equals -1. And our u was cosecant. Cosecant is harder to work with than sine. So what I'm going to do is, instead of working with cosecant, I'm going to flip these fractions and make them into sine. So sine is -1/2 at 7 pi over 6 and 11 pi over 6. And since those do not make a straight line on your unit circle, you would plus 2 pi k those. And when we flip -1 over 1 to get sine, we just get -1. And sine is -1 at 3 pi over 2. Since that's the only place, again, we plus 2 pi k there. So 3 solutions for that problem.